All right, what up, everybody? This is Mr. Stan coming at you with another physics video. This time we're talking about plane mirrors, right? And so, first of all, what is a mirror? What makes something a mirror while other things are not mirrors? And the answer lies in what happens to the light rays as they come and hit and bounce off the surface of whatever, bounce off a solid surface. And so, if the solid surface is really, really, really smooth, I mean, at the microscopic level, really smooth, then when the light rays come in, right, two different light rays will bounce off, and they'll be the same space apart when they bounce off on the other side. Whereas if you have a rougher surface, then one light ray will come in, it will bounce off one direction, but you see this other light ray comes in and then bounces off a completely other direction. And so you wouldn't be able to, your eyes would not be able to put together the image that um, it would have had if it was just able to look at the incident rays. Okay, so the one on the left would be a good mirror, and the one on the right would be a bad mirror. Okay, so just imagine that maybe someone had the word "hi" on their T-shirt, and the light rays would bounce off those letters, and some of them would head towards the mirror, the surface here, and bounce off. And the same thing for this rough surface. So imagine that the light from this H would head towards the mirror, bounce off, and it would be over here. So if your eye was over here, it would see the letter H. Whereas here on the rough surface, light from the letter H would come down here, bounce off here, and it would be over here. Okay, then light from the letter I would bounce off the smooth mirror right here and bounce off here. So you notice that the light from the letter I would be the same distance from the light from the letter H as it was in the beginning. And so the reflected image would look like the object. Okay, and we use those terms a lot, object and image. But object is what is really there, and then image is what you would see. Whereas on the bad mirror over here, the light from the H would bounce off to the left, and the light from the I would bounce off over here to the right. And so, if your eye was looking at this, it couldn't tell. It wouldn't be able to put together a picture of what this word was. And we keep in mind that the precision of this is going to be much smaller, right? So that um, you wouldn't even be able to see the letter H because the light from the letter H would bounce off in lots of different directions. All right. So in order to be a good mirror, it needs to be smooth. All right, even on a microscopic level, right, and that will allow it to reflect things off with the same um, orientation and same spacing as you would see in real life. Okay. So to see an example of what the light rays do, let's look at this example here. Cockroach is 2 inches tall and he stands 5 inches in front of a mirror. All right, let's talk about what the light would do and what he would see. Would he be able to see himself? If he does see himself, what would he look like? Well, keep in mind that light from his head is going to go to the mirror and it's going to bounce off, right? And if you did the whole law of reflection thing, like we learned about in the last video, you'd see that it would bounce off pretty much straight back, right? Because the perpendicular line would be like this, and so the angle of incidence would be basically zero, and so the angle of reflection. So the light would come back, and he would see the light that came off his head. However, his brain does not know automatically that the light bounced, the reflected off somewhere, right? And so what he would see, this light has traveled 5 inches here and 5 inches back. So it would look to him like that light had traveled for 10 inches. But he wouldn't know that it reflected here. So to him, it would seem like that light was coming from somewhere 10 inches away in this direction. So there's 5 inches to the mirror, it would appear to him that it was from something 5 inches behind the mirror, right? And so he would see the top of his head as if it came 5 inches from behind the mirror, even though there's probably nothing but wall behind there. Now, light from his feet would it would go in all directions, but the direction we're interested in would be halfway up his body. Okay, so if he's 2 inches, then this light ray from his feet would land up 1 inch, and that would give it. And then if you do the angle of reflection, it would bounce off here to the 2 inch mark. All right. Um, Now, with using the law of reflection, this angle here would be the same as the angle here. And it ends up so being that this would have to be halfway up the mirror for it to bounce off. Now, to him, he doesn't know it bounced halfway up the mirror. Okay, his brain is telling him that there is light that's coming from a distance of twice this, all right, this twice this hypotenuse, and because you have the incoming ray and then the reflected ray, and it would look to him as if it's coming from a direction straight down here. And so if it was that far away and coming from this direction, then it would appear to be coming from down here. So even though there's no real light coming from this direction, the light that he's getting, the one that bounced off the mirror and back, would appear to be coming from down here. Okay, so it would look to him like his feet were down there. And you could do light rays in between here and here, and I'll do that. And that would fill in the remainder of the image. So Cockroach would see himself, um, and it would appear to him like as if he were behind the mirror. And using some basic geometry, we know that this angle is the same, this angle is the same, and these end up being similar triangles. So if he's 5 inches away in the beginning, that means his image is going to be 5 inches behind the mirror. Okay, Cockroach sees what's called a virtual image. And a virtual image just means that there's no light and no real light that's going from here to here. Okay, what he's actually seeing is light that bounces from here off the mirror and back to here. So for a virtual image, if you draw a line from the image, which is this, to the object over here, uh, part of that line would be virtual lines. It would not all be real light. Okay, whereas a real image would be formed if all the light rays that would make up this that bounce off this object, if you draw a line, it would be a solid line. Okay, then that'd be real, which means you're really seeing the light that comes from the object. Whereas with virtual images, the light bounced somewhere else, but your eye is constructing an image, and that image would be a virtual image. Notice something interesting right here. If we were to cut off the bottom half of the mirror, Cockroach would still be able to see himself. Okay, he'd be able to see his shoes, right, and he'd be able to see um, his head, and he'd be able to see everything in between, and even with half the mirror gone. Okay, so if you're using a plane mirror, the height of mirror that you would need to see your whole body would be half of your height. All right, so that's plane mirrors. I'll see you all in the next episode.